Hey there, fellas. See what I'm holding right here? Yep, it's a regular old battery. Now, you might think, what good is it with it being so tiny? But in this video, I suggest we use this sort of tiny battery to try and, not even try, but make a car drive. Let's go. As for what we can power using this type of battery, that would be a small electric motor, of course. The motor itself is not that powerful, but we found this on the internet. Surely you've seen this, it works beautifully. Like, very well. Granted, it is a bit noisy, but hey. Anyway, we've got our tiny battery, that electric motor, and this contraption, as well as this lovely car. Now we just need to piece all of it together and make the car drive. Let's see what comes out of this. The teeth themselves are irrelevant. Their shape, their size. What matters is their sheer quantity. That's what makes the ratio. We can leave this fragile one here. It won't be under too much load anyway. On the output side, though, we need to lower the ratio. That is some enormous reduction. Yeah, that is a lot of reduction. And the fourth gear you can't even hold in place with your fingers. Over here we can look into, we could very well even leave this one alone. It'll work for sure. But these teeth will not be able to handle the stress. There's going to be a lot of it on the output side. Of course it won't work. So we've got some scaling and R&D to do. I say we start by beefing up these teeth, and then figure out a way to make the gears more durable. As for how to go about making these gears, well, in order to make this quick and simple, and for us to be able to easily modify them, we are using a 3D printer for the purpose. Okay, so we've done some homework, some math, and this is what we're going with. That's the gear we've drawn, with more durable teeth that have less space between them. There are less of them, but these are much thicker and more durable. Like, way more so. But we have this model, and now I think it's time to start making it. At least one gear, so that we can have a proper look at it to determine how much strength it really has. Check this out, guys. The first of the gears is complete. It looks really good. It's nice and stout. And I think we have a good chance at making this work. A really good chance, even. Now, the idea was to make them somewhat small. We did the math, modified the teeth. Granted, the gear itself isn't too thick, but further down the line, stress is going to increase, I'd imagine. Meaning those gears will need to be thicker, in order to make them capable of handling the additional load. But this is a start, let's carry on printing. One benefit of this printer, you see, we're printing dual-color gears. The body is one color, but the mark is a different color. And this printer has got two extruders, which helps save a lot of time and use less material for printing. Check this out, guys. We've removed the engine from the engine bay. We've secured the gearbox. And now we just need to set up some kind of cradle for that contraption of ours, which is going to be propelling the car. Right, let's get to work. To transfer torque from the 3D-printed gearbox, we've made this shaft, it'll connect to the gearbox, and via a gear plus a belt, it'll connect to the reduction gear. Right guys, a few days have gone by, and look at what I've got right here. These wonderful gears which we've made a bit thicker, and they've got these markings as you can see. That's so we can keep track of the rev count. And we didn't even draw these with a marker. They're actually baked in. We've done this because the printer allows for using different colored plastics simultaneously, which is a cool feature. But we're doing pretty well, though this is taking a while. Around 3 hours to print a single gear. But no big deal, we're going to carry on. We'll let the printer do its thing and look on in the process. Let's go. So apparently the first and last gears will need to be printed out of carbon-reinforced plastic, because the last gears are going to be under the most load, so they're gonna need extra durability. Well, the first ones are going to be the warmest because they'll be spinning the fastest. Friction, heat, but the carbon stuff melts at higher temperatures, so I think we'd better use that lovely reinforced plastic, which also has the added benefit of being very light. We are printing a cradle out of reinforced plastic that's 40% carbon-filled, with extra thick walls to give it that extra bit of durability. And here we have the cradle, you'll see it's composite. Also, you'll notice that the areas that the gear axes will connect to have got 100% filled rims. That's for even more durability, which is definitely going to be required in these spots. Okay guys, so we've prepared all of the components that will go into our contraption. We've printed the gears, here we have the cradle, which can be taken apart. Also a bracket for installing the motor, which has also got its own gear. The shafts, some spacers to adjust the gap between the gears. Everything is ready? So let's piece it all together and test fit the thing to the car, let's go. So look here guys, the contraption that we've made is fitted to our car. Here we have the motor, and here I've got a battery. And this battery should get this car to move. From the contraption you have a belt going down. It's a regular timing belt. Down there you have a gear, a small shaft with a uni. That's tied to the gearbox. And yeah, that's about it. And the idea is that this battery will set the car into motion. But let's try it out and see how the car is able to drive, let's go. In the meantime, guys, here's what's going on. This motorized battery-powered contraption has been working for a couple of hours at this point, and in those couple of hours we have swapped out a few batteries, and one battery is good for a little bit over an hour of operation. But the car is in the same exact spot it was before. The last gear has only moved slightly. And inside the gearbox, I mean to say that the gearbox, prop shaft, rear differential and all of that, they still haven't gone through all of the slack. And after a few hours, the car has not moved even a tiny bit. Not even a millimeter. And so, well, we are a dedicated and stubborn bunch, so let's wait for a bit more. It has been 2 days, and after moving for a good 48 hours with no rest, the car has traveled less than the length of my shoe. And after doing the math, we've worked out that, well, this is all cool and everything. We are using tiny batteries, the car is moving, but the pace is just silly. But here's what we've worked out. The electric motor turns at 1800 RPM. And for the car to move 1 meter, it needs to make 27.5 million revolutions. And that in turn will take about 10.5 days to achieve. In terms of speed, well, that would be about 29 kilometers per year. Pretty impressive, huh? But the car moves, and for it to drive, say, from Novosibirsk to Moscow, that's a 3,300 kilometer drive or thereabouts, and that drive would take almost 96,000 years. Crucially, the gearbox has to be in fourth for a straight ratio. But this sort of speed just won't do, I mean. We believe in this battery and in this motor. So I think we should start bringing the pace up. To do so, we'll remove some of the gears to speed things up. We'll see by how much, what sort of pace we can achieve. And we'll see what one battery is capable of. Let's go. We've removed a lot of the gears, leaving just 4 of them. And so now, I do think the car will drive. Powered by this right here. But we won't find out for sure until we stick this in there. Let's do that and see what happens. Well, guys, you'll notice that the speed has increased by quite a bit. We can actually see the car moving. We no longer need to wait for countless weeks, or even months and years. You can very much see that this car is able to move even when powered by this sort of battery. And quite confidently, I might add. We need to measure how many meters per minute it can go. It's now going a lot faster. I'll place this right here, and we'll see how many seconds or minutes it takes for the car to travel 1 meter. Here we go. So here's the situation. To travel 1 meter, it took the car 1 minute 36 seconds. That is quite an improvement. Instead of 10 days, this now takes a bit over 90 seconds. We've brought the speed up by so much that the trip from Novosibirsk to Moscow that I mentioned earlier, instead of 96,000 years, is going to take just 10 years. That's how much faster the car has become. And with how confidently the car can now drive, I think we should measure the torque. Check and see what sort of force it can generate while pulling. For the purpose, we'll be using a simple scale. Yeah, let's see how much force it can exert. Right, guys, we've connected the scale. And now let's see how much pull this has got.
Ой.
Call it 50.
Короче.
50 kilos. What's going on back there? Is that the belt slipping? A little bit. Damn it. There is a bit of slip, but no big deal. It can generate 50 kilos of force, and that is terrific. I guess it's sufficient, but still a tad underwhelming. I think we can improve the result. Alright, so we've put 2 of the gears back in. And now let's see how well it's able to move. Let's take a look. This is definitely going to take a while. But I expect a solid result. It is moving, but very slowly. And smoothly, not in any hurry, but it's sure-footed. With 2 extra gears, it is pulling much better. It's even able to, I haven't removed the battery. Because it's, anyway, 86 kilos is the number. And that's pretty good. We added just a few gears. The speed has decreased, but the torque has increased. 86 kilograms. Right, we've added a couple of more gears. And this is going very slowly, excruciatingly so. But it is gradually pulling. But you can hear that the battery is not providing the amount of energy that the motor needs. We're looking at 138 kilos, so let's wait some more. The final figure is at around 200 kilograms. And we've identified an issue: the belt is skipping teeth. It usually copes with a lot of stress, but here it wasn't able to, which is not ideal. Still, though, it was able to pull with 200 kilos of force, which I think is comparable to the figure produced by a factory engine for this sort of Moskvich. Well, the engine might have a bit more in it, though the clutch, whatever. Let's call it 300 kilos. But this battery was almost on par with a gasoline engine, and that is terrific. Another cool thing is that this contraption held up, nothing broke, and that is just lovely. After all, we did 3D print the whole thing. Torque is good and everything, but I'm keen to drive around at higher speed, so let's strip it down a bit. Once again, we've removed a few gears, and I'm using a different battery. It's more powerful, slightly higher voltage, let's go. We are ready, let's get going. Switch it on. Oh, this is going well. But then I'm also in it now. Come on now, come on. Let's go. And I see smoke. Sparks and smoke. And something broke off. Okay then, the important thing is that it drove well, with the help of... I don't have a battery on me, but it was a small battery and that is awesome. Can you imagine how many of those an EV has? And of course, they drive very differently. But if you can get a car to move using just one battery, why wouldn't you if you have 2 or even 300 at your disposal? Of course it'll drive. We got this to work. Feel free to experiment, don't be afraid of it. And that's it for this video, catch you guys later.